All right, for this homework video guide, I will start on question number 4 from chapter 3, lesson number 5 here. Just going to find a few quick questions to kind of go through, and hopefully we'll understand the main concepts. Okay, so using only the discriminant. Okay, so there's a thing in this chapter called the discriminant, and it's just basically part of the quadratic formula, which is b squared minus 4ac. Okay, so let's go ahead and find the values of a, b, and c. So the value of a here is 2, the value of b here is 7, and the value of c is equal to 17. So basically, we just want to use the discriminant to understand how many real roots are in the following quadratic equation. So for sure, we can probably put this into Desmos and look at how many x-intercepts we have, or we can there's another thing called the discriminant, which is b squared minus 4ac, and this is another way to kind of tell how many x-intercepts or real roots we have. Okay, so this would be 7 squared in brackets minus 4 times 2 times 17. And just by kind of looking at the numbers here, then if you want, you can go to a calculator to kind of figure out these numbers here. And let me just kind of get my calculator here as well. So, I mean, 7 squared is 49, obviously. And then if we do 4 times 2 times 17, I get 136. And then if I subtract those two numbers, I get negative 87. And clearly negative 87 is less than 0, right? So when your discriminant value, which is negative 87, if it's less than 0, what that means is you have no real roots. Okay, so what that basically means is that if you did go on Desmos and graphed it, basically the graph is kind of behaving in this manner, where notice that this graph does not touch the x-axis, and if it doesn't touch the x-axis, we have no real roots. Okay, so if the discriminant is negative, then we can just jump to this conclusion right away, saying that we have no real roots. And that's it for this particular lesson. It's just really using the discriminant, which is just a part of the quadratic formula. Okay, going to question number 5, another quick question where we need to use the discriminant. We need to state how many distinct real roots are in the following quadratic equation. Okay, so let's find the values of a. Well, the value of a here is 1. The value of b is going to be 23. And the value of c is going to be 529 divided by 4. All right, so we clearly state the values of a, b, and c. And then after that, let's write the discriminant, which is b squared minus 4ac. The value of b is 23, so 23 squared minus 4 times a, which is 1, and the value of c is 529 divided by 4. Okay, once again, going to a calculator now. So 23 times 23 is going to be 529 minus, well, this 4 and this 4 will cancel off, so that gives me 529, and that gives me 0, right? So if the discriminant equals to 0, this is a very special case. What this means is that the graph is just like touching the x-axis once. So you have one real solution. All right, so here's my one real solution. So if your discriminant equals to 0, then by definition, what that means is that your quadratic has just one x-intercept. Okay, let's keep on going on. So same question, just different numbers. Using only the discriminant, state how many distinct real roots the following quadratic equation has. Remember, it's a quadratic equation because you have an equal sign for the equation and a power of 2. So that's a quadratic, right? So once again, let's find the values of a, the value of b, and the value of c. All right, so after that, you would go ahead and write out the discriminant, which is b squared minus 4ac. Let's write down negative 20 squared minus 4a and c. All right, so negative 20 times negative 20, that's going to give me 400. And then if you went to a calculator, I mean, this is 8 times 11, which is 88. And then 400 minus 88 is going to be 312. Now 312 is positive, right? So if it's positive, it's greater than 0. So if your discriminant is positive, then you have two real two real solutions. Okay, so what that means is if you did a light sketch, the two real solutions are here and here. So here's one solution in green and here's the other solution, right? So it's two real solutions. And that happens when the discriminant is positive, meaning greater than 0. Okay, let's keep on going here. We got to find the discriminant for this quadratic equation. So once again, I would start off by writing a equals to 3, b equals to -8, and c equals to -7. Actually, no, sorry, I made a mistake on that. Let's just rewrite this. So a would equal to 3. The b value is actually right here, so they kind of tricked us there. So that's going to be -7. So the b value is the number that's touching the x variable, and the constant in this case is just -8. Okay. All right, let's write out the discriminant, which is b squared minus 4ac. So b is -7 squared minus 4, which is a, and c is -8. Okay. Going to a calculator here, this is going to be 49. And let's go ahead and do this. This is 4 times 3 times 8, which is 96. Since we have two negative signs, I got positive 96. And 49 plus 96 is 145. And once again, 145, that's the discriminant. And just for extra practice, I know this is positive, so we have two real solutions. All right, let's keep on going on. All right, so unfortunately, I'm not going to do like 10 questions for this particular lesson. I'm just going to do just a few of them. And the last kind of question I'm going to do is question number 13. For what values of n does each equation have real roots? Okay. So when you have real roots, that just means you could have one real root, or you can have two real roots, right? When you have one real root, that means the discriminant equals to 0, and when you have two real roots, that means the discriminant is positive, right? So as long as the discriminant is not negative, then you're good. Okay, let's start off with letter A here. So for letter A, I guess we can say the A value is going to be n, the B value is going to be -2, and the C value is going to be 1. Right, so same procedure, right? We just kind of write the values of A, B, and C. Then we write out the discriminant, which is b squared minus 4ac. The value of b is -2 squared minus 4 times, well, A is now just n, and C is 1. All right, so if we want real roots, let's just set this equal to 0. And this will give me a 4 minus 4n equals to 0. And another case we could have is when it's positive. So let's just go ahead and write the positive case now, right? So these are the two situations where you'll have real roots, when you have one real root or you have two real roots. And then we just solve this, we just kind of solve this, right? So this is 4 equals to 4n. Divide both sides by 4, so n would equal to 1. Right, so if I go ahead and solve this, bring the 4n over, divide both sides by 4, we have n is less than 1, so n is less than 1. Okay, so when n equals to 1, we have one solution. When n is less than 2, then we have two solutions. So those are basically the two scenarios where you have real roots. All right, let's go ahead and try letter B now. A equals to 2, B equals to 20, and C equals to the letter N. Okay, so this is letter B now, right? Question B. And let's go ahead and write out the discriminant, which is b squared minus 4ac. The value of b is 20, a is 2, and c is n. And let's just set this equal to 0 because we want a real solution there, right? So 20 squared is 400, minus 8n equals to 0. If we go ahead and solve for the n variable here, we bring the 8n over and we divide both sides by 8. So if we divide both sides by 8, I believe that's going to be 50 here, right? So let me just double check 40 divided by, yeah, it's going to be 50 here. So this 50 equals to n. Okay, perfect. So that's how you get your solution there. This is for one solution. If you want at least two solutions, all you have to do is just change the equal sign to a greater than, right? So you can have 400 minus 8n is greater than 0. 400 is greater than 8n, and that just means 5. The variable has to be less than 5 to have two solutions. All right, so there you go. There's some quick questions about how to do the discriminant questions there. So a good idea to, once again, just check the homework lesson videos if you're wondering what the concept of the discriminant is. Okay, let me move on to lesson number, this is chapter 3, lesson number 6, and I'm just going to go ahead and do a few quick questions here. I may not have time to do all 10 questions. I'm just going to do a few here. Solve for x. This isn't too bad. I mean, these questions are actually quite simple. If it's positive, if you bring it to the other side, it's going to be negative, right? So your final answer is x is less than 13 minus 7. And 13 minus 7, I believe, is going to be 6, right? So x is less than 6. And if you had to graph that on a number line, I would just say that here's 6. And if you're less than 6, you're just shading over here. And you have an open circle. All right, so inequalities here, right? Okay, let's go on to the next one here. I see a negative 8. So if I bring that to the other side, it would be x is less than 2 plus 8. And x is less than 10. All right, so what does that look like on a number line? Just put 10 in on your number line, open circle, and if you're less than 10, you're thinking about numbers to the left of 10. Okay, let's keep on going on. Question number 3. I see a plus 5, so if I bring the plus 5 over, it's going to be 3 minus 5. And what is 3 minus 5? Well, that's going to be negative 2. So x is greater than negative 2. So on a number line, if here's negative 2, open circle there, and then I just shade to the right, x is greater than negative 2. All right, so some of these are quite quick. You can go through them pretty easily here. All right, so how do I get rid of this 18 there? Well, I just move the 18 to the other side. So it'll be 13 minus 18. 13 minus 18 is going to be negative 5. And then how do you get rid of this 2? Well, since it's on the bottom, you times both sides by 2. So negative 5 times 2 is going to be negative 10. So you just times it by 2. So what does that look like on a number line here? Well, here's negative 10. And you're less than that, right? So you want numbers to the left-hand side of negative 10. There you go. X is less than negative 10. All right, keep on going here. How do I get rid of this 3 there? Well, it's dividing by 3, so the opposite of dividing is you just multiply, right? So if you want to go to a calculator and type in or input 31 times 3, that's going to be 93. So I have x minus 5 is less than or equal to 93. And then what do I do with this negative 5 here? I just bring that over, so I add 5. So 93 plus 5 is 98. So x is less than 98. So for this one here, let's put the 98 here. But now you need a closed circle here, right? Anytime you have an equal sign there, you need a closed circle there. And then you just shade to the left because it's less than 98. Okay, let's keep on going. Question number 10 here. Okay, let's bring the 5x over. And we'll, at the same time, you should be very comfortable with moving the plus 7, right? So we can interchange those two terms at the same time. So if I bring the 5x over, it's going to be negative 5x, less than or equal to negative 9. And if I move the plus 7 over, I get negative 7. Okay, so this gives me negative 2x, less than or equal to negative 16. And you got to be careful with these ones here. If you're dividing by a negative number, you actually have to flip the inequality sign. So x is greater or equal to 8. Okay, so just remember to flip that inequality sign if you're dividing by a negative number. And what does that look like on a number line? Well, here's 8. We need a closed circle, and we just shade to the right-hand side. And just remember, if you have an expression, the reason why you're flipping the sign is I think everyone agrees that 5 is greater than 2. And if you multiply both signs by a negative sign, clearly negative 5 is not greater than negative 2, right? So that's why you need to flip the sign when you're dealing with negative operations there. All right, so that's one little trick that you have to remember with inequality signs. Okay, let's move on. Okay, let's move the 7x and the positive 7 to the other side. So a negative 6x minus 7x is greater or equal to 33 minus 7. Okay, so negative 6 minus 7 is going to be negative 13x, greater or equal to. And now let's go ahead and figure this out. So I have 33 minus 7, which is 26. And then you can divide both sides by negative 13. Now remember, you're dividing by a negative number here, right? So that means the inequality has to flip. And this is going to be negative 2. If you want to draw this number line, here's negative 2. And you have a closed circle. And you're shading to the left. Okay, question number 12 here. Let's just go ahead and distribute this. So 2 times 6 is 12x plus 30 less than or equal to, if I distribute that, I get 24x plus, and then if you distribute that again, what you're doing there is 22 times 3, which is 66, right? And then from there, let's go ahead and circle the plus 30 and the 24x. Let's bring this over to the other side. So 12x minus 24x less than or equal to 66 and then minus 30. All right, so we're going to change those signs when we're bringing those to the other side. Okay, so 12 minus 24, this will be negative 12x. And 66 minus 30, that gives us 36. And once again, we're dividing by a negative number here, right? If we're dividing by a negative number, we need to change the inequality sign to the other way, so I'll be negative 3. All right, x is greater than negative 3. If you want to draw that number line, here's negative 3, and it's going to be a closed circle, and you're going to the right-hand side because you're greater or equal to negative 3. Okay, let's keep on going. That's it for lesson number 6. So this will be chapter 3, lesson number 7. So once again, I'm just going to pick just a few quick questions to do, and this one's a bit different because we're solving quadratic. We're solving quadratic inequalities here, right? So consider the number line before, okay? And we got to find the inequality which describes the solution. So these are the solutions, negative 1 and 3. So if you have to create quadratic, you need the opposite sign. So what's the opposite of negative 1? Well, it's plus. So x plus 1. And this is positive 3. The opposite positive 3 is x minus 3. So just from that, I know that a and b don't work, right? And if I kind of draw a parabola, it doesn't matter how I draw the parabola, it looks like I'm shading between negative 1 and 3. So if you're shading between, it's going to be less than or equal to 0, right? So based on that, I guess the answer here is going to be C there. Okay, so that's it for the inequalities. And we'll draw this diagram a lot of times when we're solving the actual problems in this lesson here. Okay. So let's go ahead and try to solve these particular problems here. So what we need to do is, for question number 3 here, there's 2 parts. Let's start with A here. Let's go ahead and factor this. You're going to factor this right away. And we need 2 numbers that multiply to 15 and combine to negative 8, right? So I'm probably thinking that's going to be negative 5 and negative 3. So negative 5 times negative 3 is positive 15, and that definitely combines to negative 8. So this is x minus 5, and this is x minus 3. Okay, so if I had to sketch this, you gotta be very good at sketching these quadratics here. I would say that looking at this particular graph, the zeros are actually at 3 and 5. And since this is opening up, the graph, if I have to sketch this, the graph is going to look like that. Okay. So if you aren't quick enough to sketch these quadratics on paper like that, feel free to go to Desmos. And you need the general shape of the quadratic there, because this part right here is asking, like, this part right here, less than 0. Here's the line 0. This is 0. This question is, when is the graph below 0? Well, the graph is below 0 in this region, right? This is definitely below the x-axis. So this region is below the x-axis. So we want to say this is our particular region where the graph is below the x-axis. So here's a 3, here's a 5, x is in the middle because the answer is between 3 and 5. So when the graph is between 3 and 5, it's actually below the x-axis. And then we just write this as less than and less than. And there you go, there's your answer right there. So our answer actually comes from a graph. So I would say that the questions in lesson number 7, you do need to change it up a little bit. So these are quadratic inequalities. So inequalities have a very specific region as the answer. Moving on to letter B, I see a 9, a 2, so when I'm looking at this by inspection, I see both of them have x's. Let's just factor out the x. If I do that, I get 9x plus 2 greater or equal to 0. And just by looking at this, this means the roots are at x equals to 0. And if I set this equals to 0, I get negative 2 over 9. Alright, so if you had to quickly graph that, here is 0, and here's about negative 2 over 9. Looking at this graph, it opens up, so the graph is going to look like this. Once again, if you can't sketch this really quickly, it's totally fine. Just go onto Desmos and type it in. Now, greater than 0 means when are you above? So here's the line 0. And this question wants to know, when is this graph above that yellow line? Well, this part is above, and this part is above as well. Okay, so if I had to think about this on a number line, here is 0 and here is negative 2 over 9. I would say that it's these regions away where the graph is above the x-axis. So this means x is greater or equal to 0, and x is less than or equal to negative 2 over 9. Those are the regions, the two regions where the graph is above the x-axis. Okay, so you definitely need to adjust your thinking here, because when you see greater or equal to 0, that means when is the graph above the x-axis, and when you see this less than 0 part over here, it generally means when is the graph below the x-axis. All right, so you do need to change your mind, your thinking when you're doing these kind of problems here. I like these kind of particular problems because they're factored already. And when they're in factored form like they are in question number 7, you need to find the zeros right away. So as soon as I see this, this means there's a 0 at x equals to 0. And when I see this, x plus 4, you just take the opposite, which is negative 4, right? And since this is a positive leading coefficient, this opens up. So there's a little sketch of that graph. Now, if you can't sketch that quickly, that's fine. All you have to do is go on Desmos. Now, when you're less than 0, this means when is the graph below the x-axis, and clearly this region right here is below, right? So the way you write that is negative 4 and 0. X is in the middle, less than and less than. Oh, it didn't really come out very nice. Okay, so the lower number on the left, the higher number on the right, x in the middle, and the signs always just kind of point that way when you're talking about a region that's below, in between two numbers. Okay, so let me kind of erase this, and we'll say this is negative 4 less than x less than 0. Okay, let's move on to the next question. This is actually kind of interesting here. We have a graph here, and let's just go ahead and distribute this. So I get x squared plus 4x is less than 21. So this is a letter B. And then let's bring the 21 over. That'll be negative 21 less than 0. And the question is, can we factor this? We can. We have a 7 and a 3, right? So this would be x plus 7 and x minus 3. All right, so when you have to graph this quadratic, you could do a very light sketch. You have zeros at 3 and 7, negative 7. And this parabola is also opening up. So you have a 0 at 3 and negative 7. And this question is asking, when is the graph below the x-axis? Well, I think all of this is definitely below the x-axis, right? So the region, the x values where the graph is below the x-axis, these are all the x values, this yellow region right there. And now you need to write that yellow region as an inequality. And it's very simple. So when your region is between two numbers, this is how you write your inequality. If you're between two numbers, you take your lower number, which is negative 7, and then you take your higher number, which is 3. All right, so lower number on the left, higher number on the right. And you put your x variable in the middle, because these are all x values, right? These are all x values. And the signs just always point to the left like that. So x is between negative 7 and 3. Okay, so we got to show all that work, and let me erase this now. So the answer is, this is between negative 7 and 3. Okay, let's erase all that. Okay, let's go ahead and graph the next one here. If I set negative 4x to 0, that means x equals to 0. If I set this equal to 0, this means x equals to negative 4. So you got to be able to do that pretty quickly. If you have to do a very light sketch of this graph right here, the x-intercepts are at 0 and negative 4, right? Because this negative sign there, it's opening down now, like that. And once again, this question is asking, when are you below the x-axis, right? So this part right, actually, hold on. When are you below the x-axis? So when is the graph below that yellow line? Well, it turns out now, that if I use a red marker, this part of the graph is below the yellow line, and this part of the graph is below the yellow line. So if you had to translate that on a number line here, I mean, this x value is 0, and this value here is negative 4. What we're doing is we're talking about the regions to the right of 0 and the regions to the left of 0. So the way you write that is x is less than negative 4 and x is greater than 0. So those are your answers for that particular problem. Okay, let's keep on going here. Solve quadratics graphically. Okay, so I mean, let's just bring the positive 1 over, and I get a 9 there. 10 minus 1 is 9. Square root both sides, plus or minus 3. All right, so if you had to solve this graphically, it's just asking for the intercepts. So you have 1 at negative 3, 1 at positive 3. It's opening up, so something like that should do it. And that's it. Okay, let's move on. Solve for x. Okay, there's a negative 1 here, so you divide by negative 1, divide by negative 1. X is greater or equal to negative 9. That's it. You just change the inequality sign. Okay, and that's it.